Suppose we have a bag. What is the probability that there are 2 red and 1 blue? Now the first part just asks for all reds. Now we're looking for the probability that 2 are red and 1 is blue. This is a little more complicated because you're still looking for the number of ways to get what you want divided by the number of ways to get any 3, which is the basic probability principle. The catch is that the number of ways to get 2 reds is a little more complicated than the number of ways to get 3 reds, because once you've chosen 2 reds, you're not done. You still have to choose the blue. When you were doing all reds, once you chose the 3 reds, you were done. But if you're choosing 2 reds and a blue, it's really a double choice. You've got to choose the reds and then you've got to choose the blues. So the number of ways to choose 2 reds times the number of ways to choose a blue is the number of ways to get 2 reds and a blue. So it's a compound event. The denominator is the same as before. You still want to choose any 3. So we work it very similarly to the way we worked the other problem. You just have to write it out as a product up top, but otherwise it's the same. So it's going to be the number of ways to choose 2 reds out of 5 reds times the number of ways to choose 1 blue out of how many? Well, out of 4 blue. The denominator is just the same as in the last problem. You're choosing 3 marbles out of any of the, again, 5, 4, 2 is 11. And we already know from the last calculation that 11 things taken 3 at a time comes out to be 165. You can rewind if you've forgotten that. So really we have to do 5 combination 2, 5 things taken 2 at a time, and multiply it by 4 things taken 1 at a time. Well, 5 things taken 2 at a time is 5 factorial over 2 factorial times 3 factorial. And 4 things taken 1 at a time is 4 factorial over 1 factorial times 4 minus 1 is 3 factorial. So that's a little bit sloppy, but you know how to write factorials anyway. So on the calculator you want to do 5 factorial divided by 2 factorial, and then do again another division by 3 factorial. If you'll look at the problem we worked in A, other than the fact that the 3 was written first, that's exactly the same thing we got earlier. So it's going to be 10 just like it was before. And 4 factorial over 1 factorial is just 4 factorial over 1. So really you're just doing 4 factorial divided by 3 factorial. And that's pretty simple. I'm not going to show it on screen, but that comes out just to be 4. And if you're having trouble doing that, you need to spend some time with your calculator and get some help, because you do need to know how to do this. And now it's just a matter of simplifying. So you end up with 40 over 165, and that reduces to 8 over 33. And again, that might be a good enough answer. It just depends on what you want. If you do want to convert it to a decimal, go to your calculator, and that comes out to be approximately 0.2424. So the probability of getting 2 reds and 1 blue is about 0.2424.